Hello everyone, welcome to the second part of this lesson about how to graph quadratics. So hopefully you're able to take some time to go through and graph all these quadratics that you're supposed to graph and see what the effects have on the graph. And what you're supposed to discover is a few things. Namely, when you have a number inside here, that's going to give you a horizontal change. And if you have a number outside the squared part, that's going to be a vertical change. And then if you have a number out front, that's going to do a vertical stretch. And if that happens to be negative, it's going to be upside down. So let me kind of walk through a few of these too. So this h value is going to move it horizontally. So if this h value is 3, so you have x minus 3 squared, it's going to move it to the right 3. If it was x plus 7, that'd be like subtract negative 7, which would be moving it left 7. If you have a number out here, it's going to move it vertically. So if that number out there is 9, your whole graph's going to go up 9. If it's negative 5, everything's going to go down 5. And these together make your vertex. And once you have your vertex, you can graph other points based on that. So something we didn't look at in the last video is realizing the pattern that goes on with these graphs. So if you look at the basic one, that's this blue one, the first point with respect to the starting one is just going up 1. And then to get to the next one, it's going to go up 3. And then to get up to the next one, you got to go up 5. And chances are you're seeing a pattern. Up 1, up 3, up 5. Yeah, if you want to get to the next one, it'd be going up 7. And that's actually the same pattern that happens on all basic parabolas. Here, it's up 1, up 3. The next one would be up 5. This one here is up 1, up 3. The next one would be up 5. And if you look at this one here that we did on the last video, we went up 1, then it went up 3. The next one would go up 5. And that's how all the basic ones start out. But if you have a number out front, it's going to adjust that pattern. So instead of going up 1, 3, 5, 7, you're going to times all those by the a value. So if your a was 2, it would instead go up 2, 6, 10, 14, etc. If your a was 1/2, instead your pattern would be go up a half, go up 3 halves, go up 5 halves, go up 7 halves. And then if your a happens to be negative, your graph's going to open upside down, a lot like this one. So now you've kind of seen what those different parts do to your graph. What you should do is first find your vertex and then use your a value to find other points on your parabola and get them graphed. And so what we're going to do is we're going to look at a couple graphs here and see if we can get the equation based off of them. So I'm going to switch to blue. So number one here, I see that this highest point is up here, and that point is at 0, 9. And so if I was trying to write my equation, f of x equals, it didn't move horizontally any. So normally your parabola starts at 0, 0 and goes up. So it didn't go horizontally at all. It did move vertically though. So I'm going to put x squared plus 9. You can kind of think of this as x plus 0 squared, but when you add 0, nothing happens. But this graph is not just this, because this graph is upside down. And if I look at my points here, I can see that it went down 1, and went down 3, and then went down 5. And so this actually has the same pattern, it's just upside down. So I'm just going to put -1, or you can just put negative x. And so that's how you can get your function based off your graph. Let's go to a different one that has a different vertex. It's kind of far away, like 4 here. I can put my point here, and I see my vertex is at 5, -2. So it normally starts at 0, 0, and it went right 5 and down 2 from there. So my vertex is going to have x minus 5 squared, and then, minus 2, because it went down 2. So I got my function pretty much set up here. I just need to check and see if the a value is still 1. So this one went up 1, and then it went up 3, and then I went up 5. Yeah, so this has the same pattern as a normal one, and so my a value up front is just going to be 1, or I can just leave it, and now I got my function. Well, if we were to look at 2, I'm just going to look how it's a little bit different. Our vertex is here, but when I look here, it didn't go up 1. It's looking like it kind of went up a half. And if I look here, yeah, that's looking like it went up 1.5. And I look here, looks like it's going up 2.5. Well, that means your a value on something like this is going to be 1/2 because it's going up half as much as it normally would. So after you've seen those, let's jump to the ending here. And on the ending here, it gives you the function, and you're supposed to graph it. Let's do one where it has kind of a weird a value, like number 4. So here I see have no k value, so it's like +0. So it's not going up and down at all. Instead, here it's got +2, and that's going to move it left 2 from the initial spot of starting at 0, 0. So I'm going to go left 2, which means my vertex is going to be here. And then before I can plot other points, I have to look at my a value. This negative lets me know it's going to be upside down, so I'm going to make that upside down like. And the half lets me know it's going to go down half as much as it normally would. So normally it would be 1, 3, 5, 7, etc. It's going to be half that. So 1/2, 3 halves, which is 1.5, 5 halves, which is 2.5, 7 halves, which is 3.5. So I'm going to go down a half, and then 1.5, and then 2.5, and then I would go down 3.5, putting it here. And once you got one side figured out, the other side luckily is symmetrical, so you can just kind of copy the points over. And now I got my parabola here, like that. And so that's the last part of this assignment. You'd graph your own. So there you go.